Hey everyone, this is Derek and this is section 10.4, the parabola. And so circles, ellipses, and hyperbola all kind of go together, and then parabolas are kind of the odd conic out, so to speak. They're going to come in four flavors in just a second here. So we'll have up, down, right, and left. But let me just go through kind of one of them, and then everything applies to the other four cases as well. So with our equation, this time we're only going to have one squared. So this is basically, if I simplified this, if hk were at the origin, so, like the simpler versions that we saw with ellipses and hyperbola, this, for instance, would look like x squared equals 4ay if it's centered at 0, 0. So what we're seeing is we're going to have an x squared, which is our parabola shape that we know and love, and then this side does not have a negative sign, it's positive, and so it opens up. What we're going to see if we put a negative sign here is we're going to have a this one where it's an x squared and a negative, it would open down. And then the other two cases, what will happen is we're going to have y squared positive, which opens in the positive direction to the right, and then we're going to have y squared and negative, which opens in the negative direction or to the left. So positive goes up and down, or up and right, and then negative goes down and left. So that's kind of our four cases. Again, x squared is our up-down one that we've done a bunch with, and then the y squareds are going to open left and right. So back to the pieces on this. HK is, instead of our center, now it's our vertex. And our vertex kind of acts like a center, so to speak, in a parabola, because it's sort of at the center of where everything is happening. So that HK, that's going to be our vertex. And then the only other quantity in here is this A, and they all have it, 4A. It could be negative or positive, but what this A is the distance from the vertex to the focus. It's also the distance from the vertex to this line called the directrix. And so if A, in this case, is 4, there'll be, from the vertex, it'll be 4 up from there, and then 4 down to the directrix. And then to get the rest of the parabola, it's 2a to either side from the focus. So for instance, in this case where this was 4, so we go 4 up to the focus. Here, this would be 8 units because it's 2a on either side. So if I knew my vertex and a, I could go, okay, up 4, there's my focus, and then over 8 from there. And that would establish the rest of the parabola. What this directrix is it's always equal distance from the focus to the parabola as it is from the parabola to the directrix. So like right here, this distance in this example happens to be 4, but whatever this distance right there is, it is the exact same thing as that distance right here. Likewise, whatever that distance is, it's the same distance as that. So if I very carefully kept laying out equal distances, what you get is that parabola. So that's how the directrix and the focus work together to define it. Let's see, what else did I want to say on this? I think that is it. Let me show you a few examples. Okay, so these first couple examples, we're going to be given the graph of the parabola, and we're asked to find the equation. So first off, we look at the orientation, and again we have 4, opens up, opens down, right and left. For this first one that we're looking at, it opens up, so that means it's going to be an x squared positive for our form. And so let me write that out here. So x minus h squared equals 4a, and then y minus k. And so remember hk, that's our vertex. So to find hk, that would be right there, and that looks to be 3, -5. And then the only other thing that I need, cat invasion, there we go. The only other thing that I need is to find a. And a question I get in class a lot is, what's the sign on a? Don't even worry about a sign on a. Think of it as an absolute value. So a is 3 units in this case. Over here it's going to be 1, but don't think about left or right or up and down. We're just thinking of it as a distance. And those 4 formulas will fix up the signs. So here we know a is 3. So then basically that's, you need h, k, and a for a parabola. I got them, so now I just chunk them in the formula here. So this would be x minus 3 quantity squared equals 4, hi Aggie, equals 4 times 3, so that is 12. And then y minus k, so minus that -5, that's that reverse sign that we keep seeing everywhere, gives us a +5. For that next one, this one is opening to the left, and so when it opens to the left, it's going to be a y squared and negative. So let me write it out. So here our hk is 5, -4. And then our a is 1. And so you have to be a little bit careful. Notice up here in the formula, the y and the x change places. So it's like with the hyperbola, where you have to be careful not to go 5, 4. You have to go 4 and then the 5 on this side, right? Because that's h and k, so it just happens to be written backwards. So this would be y minus a negative, so +4, quantity squared, equals -4 times 1 would just be 4, and then x minus 5. And then we don't want to distribute this or anything. We like this form. Cat fight. Sorry, the cat's very active this morning. We like this form because it gives us A and it gives us vertex. So no need to do anything else to that. Okay, for this next one, we were asked to find basically all of the stuff. So vertex, focus, axis of symmetry. I'll show you what that is. And the directrix given the equation. And we'll see the same thing in this section as we did in the last 3. We'll be given the stuff and then asked to find the equation next. So this is an x squared and it is negative, so that means it's going to be opening down. And then to figure out what A is, again, don't worry about the sign on A. You know what it's going to do. It's going to open down, and that's all you need. Just think of A as a distance. So we're going to say 4A would equal that 20. And again, the sign's opening down, so we'll divide the 4 and get A equals 5. So that gives me kind of all of those distances that I need to actually graph this. So our vertex is at 0, 0. So that's the first thing. And then our focus, we know it's opening down and A is 5. So that is going to put our focus right there at -5 because it'll be 5 units below. So focus is x is 0 and y is -5. And so once I have that, now I can draw the rest of the parabola. So again, if this is A, then from the focus to the parabola is 2A. So this is 5, so this would be 10 and 10. So you have kind of this big, wide parabola opening down. The axis of symmetry, so that is like the fold line. So that is right there. So it's that vertical line. So axis of symmetry would be x equals 0. And remember, x equals like our asymptotes, our vertical asymptotes. It's like that, so it would just be what we would fold over. And then the other one is the directrix. And that is, so if this is our vertex and A is 5, our directrix would be right up there. And that would be at y equals 5. Okay, so this one is an x squared and positive, so we know it's opening up. The vertex is going to be right there, our hk. So our vertex is -1, +2, those same reverse signs you can see in. Get that graphed, and then, so 4A equals 12, and so A is 3, so that's going to give me all my distances. So when x is -1, y is the other way, 2. And then A is 3 and it's opening up. So that gives me my focus would be right there, which is -1, 5. And then my directrix, that would have to be 3 below it. So it's going to be right here. And that is y equals -1. And let's see, A was 3, right? So let's get the parabola finished. So 6 that way, and then 6 that way. So you get something kind of like that. And then hopefully that helps to show there's our axis of symmetry now. So that's if I folded it over. And so axis of symmetry would be x equals -1. Okay, just like we saw in previous sections, for this one, we would need to complete the square. And when we did this with circles and ellipses and hyperbola, we had to complete the square twice because there were 2 squares. So this time we're only going to need to complete the square once because we only have 1 square involved in the problem. So this one's going to be a y squared. So what I want to do is keep everything. If you can't remember how these formulas end up looking, we end up with the y squared on one side and then everything involving x on the other side. So that's kind of our goal. So I'm going to take this and rewrite it as y squared minus 4y. I'll leave myself some space there to complete the square in a second. Equals, and then bringing this over gets me -8x. Bringing that over gets me -28. And now I'll complete the square. So half of 4 is 2, and then squared would make 4. So that's what we need to add to both sides of this. And now this is our perfect trinomial square. So that's going to be y minus 2 quantity squared. And then combining terms here, -8x minus 24. This is the step where everyone misses the problem. This right here is where you'll mess it up. It is factoring that silly little -8 out. So we want this to look like 4a and then parentheses x minus or plus something. That's our goal. So we need to get the common factor out. And here it is. We want to make sure, remember the sign comes with the number, so we want to factor out the negative. And that makes this positive. And that sign change right there, -8 times 3 really makes -24. People very frequently forget to take that sign, and that ends up being the spot where they're a little bit wrong and frustrated. Then the next spot to get this a little bit wrong is to, remember this is KH, not HK. So our vertex in this case is going to be -3, +2. So absolutely everything backwards. And then over here, 4a was 8, so a is 2. And again, that just tells me it's going to open in the negative direction, which in this case is left because of the y squared. So let's get this graphed. Our vertex is that x is -3 and y is 2. And then our focus is going to be 2 away from there, and we're opening, yep, left. So that's our focus. So that's -5, 2. And so then our axis, actually let me finish drawing it. Let me do that and that. And there we go. So then our axis of symmetry would be right there. That would be at y equals 2. And then our directrix, that would be if a is 2, then it would be 2 behind it. So the directrix would be right here. And that is at x equals -1. Okay, for these next ones, we're going to be given the stuff, and then we're finding the equation this time. So, given the stuff, equation with a focus at -4, 0, so x is -4 and y is 0, vertex at 0, 0, so we're centered at the origin. Remember, the parabola is going to kind of, think of it as like a Pac-Man. It's going to eat the focus. And so this is opening to the left, so it's going to be a y squared and a negative. And when we, this one is centered at the origin, so it's going to literally just be y squared equals -4ax when I let that h and k be 0. So y squared equals -4. What is r? That is 4 there, so that'd be a negative, a is 4. So this would be -16 x for our equation. And then just to finish getting this drawn, so if a is 4, then our directrix would be 4 behind it. That would be right there. And then this would be up 8. And then this would be down 8. And opening to the left. Okay, for this one, we are given a focus at 2, 4, x is 2, y is 4, so that's right there, and a directrix at x equals negative 4. So that would be like right here, is what that is telling me. So I know that the vertex is halfway between the directrix and the focus, and so just looking at my graph, that would be right there. So what that does is gives me an HK of negative 1, 4. And then it is opening right. And so that means it's going to be a y squared and positive. To finish getting it graphed, we got a of 3 there. Just again, I'm reading the number boxes on the graph. So 3, 6 that way, and 3, 6 that way. And we get that. So that would complete the graph. And then to get the rest of the equation, let me write it out. So that's what I'm plugging into, y squared positive. And then again, careful, this is h and this is k, so we just got to get them put in the right spot. So 4 squared, 4 times a was 3, so that's a positive 12, and then x minus a negative 1, and so plus 1. Okay, and then these last couple are just a couple of application problems. So an arch is in the shape of a parabola. It has a span of 320 feet and a maximum height of 16 feet. Assuming the equation of the parabola for this arch, assume the origin is halfway between the arch's feet. And so I will get a drawing of kind of what that looks like. So we're trying to find the equation with the origin placed halfway between. Okay, so there's my arch not drawn to scale. So I'm going to have a vertex up there, and then I'm told that the span is 320 feet. So I know I'm 320 feet this way and this way. And I know that this is 16 feet. So if this is 320 total, then what that means is that this is 160 on either side. And then we're supposed to find the equation of the parabola, assuming the origin is halfway between the arch's feet. So here is our origin as defined by that sentence. And there's lots of, we could put our origin right here. We would get an equation, it's just we would have defined our axes different. When we got to B, we would have actually found the same answer, but we have to be careful to define it the same way that they're asking. So if this is 320 feet from here to here, and this is 0, 0, so there's my axes, then that makes this point 160 and 0, and then this point over here would be negative 160 and 0. And then here they're also saying that it's 16 feet high, so this is x is 0 and y is 16. And that is super important because that is our vertex. So this is an x squared negative, so it's going to open down. And let me write out my equation right here. So that's what we're plugging into. We're going to have x minus, for a vertex, that coordinate's 0, so that's just going to be an x squared equals negative 4a. So here's where people mess this one up, is that's not the focus. There's nothing in here that says this is the focus. It would be great if it were the focus, but there's all it says is that's the origin. So we really do not know A. You can't pretend like it's 16 because it doesn't turn out to be. But we do know K is 16, so we'll toss that in. And then just cleaning that up a little bit to make it look nicer, x squared equals negative 4a, and then y minus 16. So I'm closer, but I still need to find a, which is totally cool because I have either of these points that I know an x and a y. So I can just plunk those in for that x and y, and then that's going to actually let me solve for a. So let's see, we're going to have 160 equals negative 4, a is what we're trying to work out, and then y is 0. So negative 160 squared was 256 zeros. And the negative and negative makes a positive 64a. And then dividing that over, we'll get a equals 400. And so then plugging this into right there, my equation is x squared equals negative 1600 and then y minus 16. So that's my answer for part A. There's my equation. Again, I need my origin there so we can see our vertex, and then I solve for A. Part B is asking us to determine the height of the arch 127 feet from the center. Okay, so if we go out here 127 feet, so we're at 127, what that's doing is asking us to find that height, which is our y value. So we know our x is 127. And then it's asking us to solve for what would we get for y in that instance. So it comes out 116, 129, negative 1600y, and the minus for a plus there, and then 2560. Subtracting that over, I get negative 9471 equals this negative 1600y, and then dividing. And it looked like the answer was to 3 decimals, so 5.919, and this is in feet. Okay, last one. Suppose that a satellite receiver with a parabolic cross section is 36 inches across and 12 inches deep. How far from the vertex must the receptor unit be to ensure it's located at the focus of the parabola? So again, let me get a little drawing here. Okay, there's my attempt at a parabola. So we know its cross section, it's 36 inches across. So that means right here, we know that is 36 and it's 12 inches deep. So we know from here to here is 12. So what that tells us is this point right here, this would have to be 18, and this would have to be negative 18. Actually, I should say, first off, notice I'm putting my vertex at the origin because I can. I could have put it anywhere I wanted, but that was the easy spot. So I'm letting HK be 0, 0. So then here, to get to this point would be X is 18, and then again, it's 12 inches high. Doesn't mean that's where the focus is. It just means that's how tall the dish is. But that does tell us a point on the parabola. So 1812, or likewise, we could also use negative 1812. Again, there's our vertex at 0, 0. So this is opening up for the orientation I picked. You could have picked a different one and we would get the exact same stuff. So it will reduce to x squared and then 4a times y, because that minus k and minus h drops out. So I'll use that point, and what I'm doing is finding a. Once I know that, then that's it. That's going to be where the focus would be. So 18 squared equals 4a, and y in this case is 12. So 324 equals 48a, and then divide the 48 over. And as a fraction, which is how the computer had the answer, which I think is silly, but just in case, 24/7. I personally just threw it in the calculator and got 6.75 inches. And so again, this is that distance from the focus. I just found A, and A is defined as vertex to focus. So if this is a parabolic dish, what happens is it collects the signal and it reflects it. Everything gets reflected to that focus point. So that's what it's doing, is asking us to find where to put that. Cool, so that wraps up conics.